this part, again, this is the second part of the course. So in this second part, we will be going through different topics. So cryptography is the basics, and then we will go through all the other aspects of computer network security. So we'll see wireless security, then software security, then network security, then malware, web application security. So all these, because the field is really very, very big, very large, we'll try to cover the essential parts. So we'll start by wireless security. Wireless security is quite complex. No, there are a lot of details because it has a lot of details from
physics and signals.
Yeah, so digital communications, basically. Okay. So we'll focus on the security part. So if you go to your textbook, the chapter 6 of the textbook, you will have basically two parts. Okay, one first part about Wi-Fi security. Okay, and one other second part is about WAP security, which is called what? Wireless. No. Basically, when we talk about WAP security, it's quite an old topic because it was based on the fact that wireless devices, mobile devices, are slow machines which do not require all the processing capabilities or do not have the processing capabilities of desktop. So they designed a kind of a platform for those particular devices, taking into consideration those restrictions. Okay, and then they defined, for example, WTLS, which is a weak version, small version of SSL, of TLS. Okay. So we will go through that, but we will focus more on the Wi-Fi security. So yeah, the first part. Now, 802.11. This is a set of, it's a family of standards related to wireless local area networks. Okay, because this is very known buzzword, 802.11. It's a set of media access control and physical layer specification to implement wireless LAN. So basically, wireless networks. So the base version has been released in 1997. So it's quite recent in a type of technology compared to other protocols. So since initially I think they came up with 802.11a. Okay, it was normally in 1999, and then they every 2 years they came up with an improvement over that. So this is why they call it 802.11. We have A, then B, we have N and G. Each one of them is an improvement of the previous one. Okay. So the frequency bands are 900 megahertz, 2.4, 3.5, 6, 5, and 60 gigahertz, because it works on different frequency bands. These are the terminology when we talk about 802, all this family of standards. We have access point. So basically, the access point is the wireless router, let's say. So basically, this is the station that allows other wireless devices to get connected. Basic service set. This is a set of wireless devices with an access point. This is, we'll see a diagram. Coordination function is not very important. Distribution system. Basically, when you have any wireless device and an access point, the access point should be linked somehow to internet to provide the networking capabilities. Okay, so that part of the network which connects the access point or the basic service sets to internet, this is called the distribution system. Extended service set, ESS, is a set of BSSs. So basically, always when you think about your wireless home network, this is a small version. Okay, when here what we are talking about is a little bit larger than this. Okay, so you put basically here the scenario is an organization that provides wireless access to its, like KFUPM for example. KFUPM, what we have a lot of access points. We don't have just one router somewhere which providing all the network to everybody. We have several access points, okay? And basically, if you are in a certain location, you have a wireless device, you will be connected to one access point. And if you move to somewhere else, you will be associated with another access point. Okay, so basically an access point and all linked devices, this is called BSS. Okay, if you take several BSSs, so several access points with their associated devices, we call it ESS, extended service set. Okay, so basically extended service set, it contains several BSS and it constitutes a logical single local area. Okay, if you are part of the ESS, for user, it's transparent. It seems to you that you are linked to the same network. Okay. The frames in wireless networks is called MPDU, MAC Protocol Data Units. Information that is delivered as unit between MAC user. This is the MSDU. Anyway, this. Now, I was talking about wireless devices. In the terminology, those, if you have a device, this is called station. So we call it station. The station is the wireless device, and the kind of the router or the access point is the access point, not the station.
So what's the difference? Is it the physical device? It's a access point.
Yeah. The physical device is the station, and then the access point is the router or whatever.
Okay. They are like different. Like
of course. Yeah. Here the access point is the device with antennas that provide the service. Okay, the device is the device. The station is the wireless device.
Which is the same, like it's usually integrated, right? Or maybe not.
Huh?
It's like your mobile phone.
Oh, I see.
If you at home you have a wireless router.
Yes.
I guess. Okay, so basically your device, your mobile device, okay, your phone, this is the station, and your wireless router, this is the access point. Okay. As I told you, the first mainly used version of the standard, it's 802.11b. Formed in 1999. So to assist interoperability of products, this one was renamed Wi-Fi. Wi-Fi stands for Wireless Fidelity Alliance. Create the test suite to certify interoperability initially for So the first one, 102.11b, and since that time, as I told you, several other amendments, so improvements over that have been introduced. And see here, it gives you an idea. So this is the release date. This is 802.11a, b, g, and n. These are the dates. These are the frequency on which they work. Okay, they don't work on the same frequencies. And then the bandwidth in the frequency. And then you have the data rate per stream. So basically how fast it is. Okay. So see here for the first one is 1 megabyte per second. Okay, 1 or 2 megabyte per second. Then while we are moving it, so for the last one, 802.11n. So basically, if you buy a wireless router, you will see these things. You will see which version of the.
Yes, sometimes they list all the versions.
All the version that you can, but you can change them. I guess it supports all.
I think it doesn't do automatic.
Yeah. So you have a default one. See the latest one we are talking about 150 megabytes per second. This is the range, so how far it can go. So basically indoor, it's 20 meters for the first one, then up to 70 meters indoor. Okay, outdoor is much larger, so 100 meters, 150 meters.
What do you mean by indoor and outdoor?
The range. If you are inside house, okay, where you will have walls, the signal will be will reach less distance. Now, this is the protocol stack, or the network stack of IEEE 11. In wired networks, the stack contains how many layers?
5.
This is TCP/IP, right? But the OSI is 7. Okay, so here you have 3. Okay, but they are mainly for physical kind of physical layers. So see, the physical layer is in charge of encoding, decoding of signals. Then bit transmission, reception. So it's about that. Because the signal is transmitted in analog signal, basically. The data will be encoded and modulated into analog signal. When it is sent, it's sent analog signal, and then if you need to retrieve back the bits, you need to do all the opposite, the process on the opposite side. So you demodulate it, then you decode it. So you have this is basically what you cover in courses like wireless communication or digital signal processing. Okay, the process is similar to what we have in wired communication. Okay, it's also a signal, analog signal, and you need to modulate it and do all those things. At the medium access control layer, basically you assemble data into a frame. You do error detection, addressing, and then at the logical link control layer, you do flow control and error control. Flow control, basically we do what? Flow control.
Make sure that the receiving rate is equal to
It's not overall.
Make sure.
sending rate and receiving rate.
Both parts.
Yeah. No, this I would guess it's the physical layer. No. This is in charge of physical layer. Everything related to the rate and the physical properties of the signal, it's here. Okay. Now, flow control basically, if a packet is lost, let's say, if some data is lost, so you take care of it here. Okay. So you will find out here at this level. Okay. And error control, same thing. Yeah.
So, is that the logical link control is not available in 802.11?
No. This is specific function for 80. This is 802 function. This is 802.11.
There's general specific.
Yeah, this specific. Basically, they are only implemented 802.11.
Yeah, which is the wireless technology.
Yes, here what it means here. What you have here, it's in the general. So we find it in every 802 protocol function, yani protocols. Okay, but here they are specific, meaning this we find them only in the wireless version. Okay, this one basically is exactly the same as the wired version. Yes.
What is the difference between flow control and error control?
Error control, here we have error detection. So you detect if there is an error.
The packet, same packet.
Yeah, so error integrity, for example. There is a packet which reached, but there is a couple of bits which have been changed along the way. So you find that part. How you find that?
Checksum.
Checksum. Okay, checksum. There is an error. You detect it here, and then you try to correct it here, error control. So you try to basically fix it here. Okay. So here, fixing the error, basically, how? You need to reset. Okay. Flow control, it's related to error control, but sometimes the order of packets, okay, the order of the flow. So if you have a window, for example, you take care of that. Window to discard old packets, basically. Okay.
Does it include the routing? Does it include routing?
No. At this level, no. So logical link control, it's not about routing.
Because routing happens in the router, this is in the device.
This is
Because the station, this one.
you will find them both in both. In this protocol stack, it's in both. If you need to communicate between a station and access point, you need to have this in both sides. Okay. Wireless, we don't care about routing. we care about routing when we deal with the wireless. The next. So this is a complete picture. As I told you, if you have an access point and several stations associated to it, this is called basic service set. Okay, and this is another basic service set with another access point, and then the access points are linked through a distribution system. So do we care about routing? Do we care about routing? Because the protocol stack we saw is only implemented here and here. Okay, so it's about sending data from source to destination. With wireless, you don't care about routing. Okay, because you connect right away to the destination. It's, if in wired communication we have a wire between every two machines, do we care about routing?
No.
We will not care. Okay, because you need to communicate with one machine. So when you want to communicate with Google, for example, you have a wire from your machine to Google right away. Do you care about routing in that case? No. Okay. Here the same thing. If you're on a station, you need to send data to the access point. Okay. And then from the access point, it will take care of routing this. Now here, what you have in distribution system, this one it might be wired, it might be wireless, but this is the job of the how access points communicate between each other. Okay. Now we saw the extended service set. So here the extended service set is what?
Both of them.
Not all of them, just these two. These two. This is a constitute extended service set. Okay? Yeah. So extended service set is a group of access points with the linked devices. Okay.
Are there possible groups or only the selected groups?
It depends on how you implement that. So, for example, if you have a single local area network, okay, that contains you define it to contain 3 access points. This will be your extended service. Okay. Yes.
So distribution system like mobile and electricity.
No.
See, distribution system is in charge of routing and forwarding the traffic between access point and access point. Now, let's think about KFUPM. Okay, you have several access points. These access points should be linked together, right? Somehow, through the wire, through what we have here. I think it's wired. So basically, all the access points, what you have, the devices which are everywhere, they are linked wire. Okay. So this is one version. Okay. Now, of course, these access points are linked to internet. Okay. So if you look to the big picture, that distribution system, it might contain what we're talking about, I don't know, STC and the internet service provider.
I think you mean the smartphone chip, the SIM card, the 3G and 4G.
No, here we are not talking yet about 3G and 4G. Okay, here it's Wi-Fi security. This is another story. You know, the technology is different. Mobile networks are completely different from what we are talking about here. The security aspects also are different. Okay, because if you are using your mobile and you are making a call or making some internet connection, is the traffic you are exchanging with the access point or whatever, is it encrypted? Is it encrypted?
Yes, it should be.
It should be. It is. It is encrypted, but it uses different other protocols. Okay, it's a different protocol. I think for I forgot the name. I think it's called D5 or something. The cryptographic protocol uses to encrypt mobile communication. Because if it is not encrypted, it's big trouble. Everybody can intercept what you are sending. Okay. But here again, we are talking about Wi-Fi. Okay.
What's the difference between extended service set and the distribution system?
The distribution system is larger. So, for example, if we have here, let's say, 2 other access points. Okay, 2 other access points. So we might say these 2 access points form one ESS, extended service system, and the other two form another BSS. So basically, they are two different local area networks.
Oh.
Yeah. Okay.
Now,
But they can be part of the same distribution system. Yes.
for the devices inside the basic service, if they want to communicate with each other wirelessly, or they have
No. This is now the default scenario is that all the traffic should go through the access point. You need to communicate with station 3. Station 2 needs to communicate with the access point, and station 3 needs to communicate with the access point. This is default. But there are versions of the BSS where you have peer-to-peer communication. Okay, this is called IBSS, independent basic service sets. And they have different protocols, different way of authentication. Okay. So now here by default, what we will be covering in this lecture, we are covering the default one, where all the traffic goes through the access point. So you need to provide secure communication. You need to take care of this communication with the access point. Okay. Yeah, these are the services provided by 802.11. So you have association, authentication, all this. So basically, association, it's a relationship between a station and the access point. Okay. So basically here, if an access point, station needs to connect to wireless network, it needs to find an access point. Okay, there are ways to discover access points. We're gonna see it, and then it will associate itself with the access point. So basically, whenever it needs to communicate, to send some data, it will go through that access point. Now, that same station, of course, if it moves to another BSS, okay, that other BSS basically, although it's the same local area network, okay, the same addressing, everything, but it will be linked to another access point. So what it should do, it should disassociate itself from the this access point, and associate itself to a second access point. This property is called association. So in order to use the system, you need this association service. Okay. So association, this is a service provided by a distribution system. Okay. Then you have authentication. Of course, any machine needs to authenticate itself to the access point or to the system itself. Okay. Authentication. You have de-authentication, the opposite. Disassociation, as I told you, if you move from one BSS to another, you need to disassociate yourself. Distribution. Basically, distribution. It's about communication between access points. If, for example, station 2 needs to communicate with station 7, the distribution system needs to provide that service, which is distribute the traffic. I mean, through to other BSS, to other BSS and other ESS also. Okay, so it's another service, distribution. Then you have the integration. Again, here integration should be. Again, the distribution system, how it can be implemented here. Is it wireless? It could be. It could be wireless. It could be wired. So if it is wired, the protocols and the way of communication will be different. Okay, this one is wired, Wi-Fi. This one is wired communication, and you need a way to integrate all these two different technologies. This is integration, service. Okay, so even though the technology used here is different from the technology used here, you need that integration service. You need them to work together. So delivery, privacy, and reassociation. Yeah, so it's quite clear.
Is it integration between the Wi-Fi or the access points?
Between
I mean, for example, access point uses 11A.
For example, here the access point is using this BSS is using 802.11a,
yeah,
and here it's using 802.11n. There should be the frequency band will be different, the protocols will be different here. This fact of allowing the communication to go through between them, this is integration. Now, all this, it's an introduction to 802.11 technology. Until now, we did not talk about security. Now, about security, when it has been introduced, the 802.11, there was security features, okay? Because you cannot use Wi-Fi without security. Because wireless traffic can be monitored by any radio in range, not physically connected. So anybody in the range can intercept the traffic, and if it is not encrypted, if it's not protected, you can see everything. Okay. So from day one, Wi-Fi and 802.11 comes with security features. Okay. And those security features, they were implemented through the web. This is the first protocol or secure protocol for 802.11. But everybody knows, web. When you say web, it's a synonym of security flaws. It's very flawed. Yeah, it's very flawed. But found this contained major weaknesses. Okay. So 802. Now, what they did in this, as I told you, the protocol, the 802.11, every couple of years they provide improvement. So 802.11i, it's not a protocol by itself, a version of 802.11 by itself, but it's a security addition to 802.11. So that's group developed capabilities to address W9 security issues. So they came up with one first version, which is called the WPA, Wi-Fi Protected Access, and then the second version, RSN, which is basically can be seen as the WPA2. You see this configuration when you configure it. So WPA is one version, one initial version. Then a couple of years later, then they had this robust security network. Okay. Now I'll go back to web. So the problems of web weaknesses include the following: static keys that are rarely changed by users. So remember, we will talk about that. When you connect to a network, wireless network, Wi-Fi, you need to type in your password. Right? That password is in text, and that password needs to, it will be used to generate the keys and generate all the authentication and the confidentiality features. And of course, when we covered symmetric key cryptography, and we said that is the key fixed all the time for symmetric key? It should be refreshed very frequently. Okay, the symmetric key. The same thing here. If you need to use wireless communication, you need to provide confidentiality. You will be using symmetric key algorithms, and the keys should be refreshed very frequently. So the problem of web, static keys that are rarely changed by users. Okay, so the keys were kind of fixed. Here we're talking about 1999, so very old days. A weak implementation of RC4 algorithm. So most of the symmetric key operations are done through this algorithm, RC4. Okay, it's different from the ES or ICS, but it's another known symmetric key cipher. Okay, so the implementation of that RC4 was weak. We saw that among the weaknesses or among the vulnerabilities of cryptographic protocols is the way they are implemented. Because if you implement it in a weak way, okay, with flaws, etc., they might be, even though the protocol theoretically is strong, but if the implementation is not strong, you can have weaknesses. For example, if you remember, I told you about the example where the pseudo-random generator, the function to generate random numbers, is weak. If it is weak, basically, an attacker can guess the random number, and he can break basically the system. So this is among the weak implementation feature.
Is it RC4 used in streaming services?
Streaming services?
Yeah, equipment streaming protocol.
Here, this is the major, even now, even the new versions of wireless security protocols, they are still using RC4. Okay. But where else it is used, I cannot tell you. An initial vector sequence is too short and wraps around in a short time, resulting in repeated keys. Remember the initial vector? We used a lot of initialization vector in SSL, for example. And then the problem is that initial vector that is supposed to be hard to guess is too short. It's short and wraps around in a short time. What does it mean here? Wraps around in a short time.
Goes back to the.
So it's a kind of it's a number which is sequential. So you move from one number to another, from one random number to another, and then it will go back to the first one quickly. Okay. So resulting in repeated keys. And what if it goes back to the same number? It's a repeated value basically. So we will focus here on the WPA2, which is the second, the current secure protocols used in Wi-Fi. So it has 3 services, or 3 phases: access control, authentication and key generation, and confidentiality and integrity. So these, they give you the protocols used in each one of them. So in access control, it is role-based access control. I will discuss it further. Then you have authentication and key generation. They use extensible authentication protocol, and then confidentiality and integrity. They use TKIP and CCNP. So you have 2 options. Okay. Again, the confidentiality. So TKIP is used in RC4. Okay. The same which is used in web, but in a more secure way. You have CCM, which is AES. Okay. And then integrity and data origin authentication. You have hashmap with SHA-1, with MD5, with this is called MICRO, message integrity code. Okay. Then another one, AES with CBCs, chain block ciphers. Okay. And key generation with basically here the key generation to generate the keys. They use SHA-1. Basically, they have a couple of some random data, and then they compute the hash, and this will be the key. Way to generate keys. This is the process. Initially, the initial phase. So here you see the players. We have the station, we have the access point, we have the authentication server, another entity, and then the end station, which is the destination of the traffic. So initially, the station needs to discover the access point. Then you do a kind of authentication with the authentication server. Then you need to exchange keys, okay? And then the secure communication and the connection termination. Yes?
In phase 2 and 3, do I skip the access point? Go.
Phase 2 and 3, yes. Basically, the access point in phase 2 and 3, it will just forward the traffic to the authentication server. But here, let's talk about the authentication server. This is not an entity. You'd say, when I have wireless router at home, I don't have another server. Basically, everything once in a router that will do all the stuff. Now, what happens in small networks? The authentication server will be at the same location as the access point, so it will be the same device. Okay. But again, what I will be discussing here, it is not the small home version. Here we are taught it's more like the KFUPM wireless network. It's larger and it uses more complicated processes. Okay. The discovery and authentication phase. So basically, the discovery here, basically the station needs to discover the access point, and the discovery it might start from the station or the access point. Okay. So the station might look for access points in the around, okay, by sending a probe request basically to multicastle, okay. Or sometimes the access point will send some advertisement. Some advertisements called the beacon messages to find the new stations in the range. Okay. AP sends possible security parameter, and here you will see it's similar to SSL. Basically, you need to do kind of authentication, and you need to exchange security capabilities. Basically, you would say, what are the security protocols, cryptographic protocols I can support? Okay. Yeah, probe request, probe response. This is for discovery. Then open system authentication request and open system authentication response. System request to perform non-authentication. Again, see here. System. Yeah. The authentication server is only involved at the stage. Okay? All this is between the access point and the. It's here. The step of authentication is not really authentication. It's the authentication between the station access point, not yet the authentication server. I talk about the control port. Control port block. So here, the access, how the access control is done. Basically, this is, suppose this is access point, and this is a station that needs to join the network. So it will discover this access point, and then it will try to reach the network. Now, initially, since station is not yet authenticated, it will use what we call an uncontrolled port on the access point. Okay, so an uncontrolled port, basically, it will be dedicated for all non-authenticated station yet. As long as the station is not authenticated, it will be using an uncontrolled port. Once it does all the steps of authentication and key agreement, etc., it can use a controlled port. Okay, so basically, this is a way to control the access. If you're not authenticated, you will use a special port, and that special port will just forward the traffic to the authentication server. Okay, so that do finish your authentication and the key agreement process, and then you will be allowed to because the point here is that authentication server is just used for authentication. Once it is done, the access point will just forward the traffic to other stations or the distribution system. Okay. So this is when we say access control is controlled by controlled ports. This is what it means. Basically, there are special ports just for non-authenticated station yet, and controlled port, other ports for secure and authenticated stations.